Discussion. Based on our empirical outcomes, the following arguments will focus on 5 significant concerns: limitation of the XREAP tool, the ratio of requirements elicitation, divide and conquer, complexity assessment, and decision-making guidelines. As the utilization of the XREAP tool to make some decisions for several projects, we found some pros and cons. They are listed in Table 3 for the analyst further reference. Furthermore, the XREAP tool owns some limitations. For example, the Mind Brainstorm function supports graphical user interface for user requirements by categories. That is, every PMI item can provide a number of the entries. However, the arrangement of the requirements map is not so concise that some of the requirements might be overlapped each other, and the screen will be too small to browse while every PMI item is more than 15 entries. Pros and cons of the XREAP tool. Fundamentally, the requirements elicitation is the first phase in our decision-making process. As most of the decision makers known, the higher ratio of requirements elicitation is obtained, the better quality of decision-making will be executed. If decision makers are eager for the highest quality of their decision-making, it is necessary for them to try to focus on the requirements elicitation phase. Fortunately, our proposed methodology can elicit required information from users by utilizing the XREAP tool. Meanwhile, the implicit information for persons, actions, tenancies, environment and equipment can be elicited by the XREAP tool as possible, as it could extract from user requirements by both PMI and APC methods. Furthermore, all requirements are listed within a tabular frame in the XREAP tool, and it is convenient for the decision makers to browse and review. As compared with other decision-making tools, we believe the XREAP tool can supply the exhaustive capability to elicit user requirements. If the problem is too large to solve, it is feasible for problem solvers to utilize the divide and conquer approach to decompose the problem into several smaller problems. If the smaller problem is still too large to handle, problem solvers can divide such a problem again until they can cope with the scope of the problem. The divide and conquer methodology is widely used in several fields such as computer science. Similarly, the decision makers are problem solvers. Therefore, decision makers can try to analyze the small problems one by one and integrate all solutions into a total solution for original problem. Generally speaking, the complexity assessment is not an easy task. As our proposed methodology illustration, the complexity can be counted for the numbers of the actors and use cases in the final use case diagram. The more actors and use cases, the more complex interwoven network for requirements will be presented. Although the roughly count of the use cases and actors might be too simple to convey the complexity of the requirements, such a computation method is easy for decision makers to confirm the existing input requirements quickly and repeatedly. However, it is possible for researchers to propose better complexity assessment for the XREAP tool in the future. Based on the complexity assessment results, decision makers can conveniently make their decision. Although the XREAP tool is one of the simple software for eliciting requirements, it can become a supplement to improve the decision-making quality for decision makers. Normally, it is necessary for decision makers to refer the decision-making guidelines that are gathered by other decision makers. As the popularity of the Internet, it is possible for decision makers to share and revise their decision-making guidelines in the cloud. Based on the knowledge management experiences from the healthcare field in 2008, it is feasible to share, revise and manage the specific knowledge through the network. That is, if the decision-making guidelines are utilized and revised by most decision makers, then the optimal decision-making process will be generated.